Insurance companies would like to understand association between healthcare cost and aging. So, as you age, the healthcare cost increases. So, there is always a relationship between an independent and a dependent variable, and that relationship we are trying to understand. An organization may be interested in finding relationship between the revenue generated from a product and the features, depending on whether the revenue generated from a product depends upon the price of the product, the promotional amount spent, the competitor's price of similar product, and etc. There could be other features as well, depending on the product we are talking about. Restaurants would like to know relationship between a customer waiting time after placing the order and the amount of revenue generated. Let us say if the waiting time is very large, then maybe the customer goes away. Similarly, there are many e-commerce websites who would like to understand the relationship between the revenue generated and again the features like how many customers are visiting to the portal, how many clicks are there on the products, the number of items which are on sale. So if the more items are there, then it does the revenue become more? या ज्यादा items को sale पे डाल दिया तो revenue कम हो जाएगा because you are giving discount. How much average discount percentage people का impact लोगों पे पड़ता है. बहुत ज्यादा discount है तो maybe the people start feeling that this product is of lesser quality. That is why so much discount is given. Likewise, so these companies have to do so much of analytics, and that is why, or that is how their business grows. Then we have banking and other financial institutions who also use regression models to understand the impact of unemployment rate, marital status, bank balance on percentage of non-performing assets. So again, many people are there who have taken loan, they are not able to return back. So all of this study has to be given so that there are lesser losses to the financial institutions. So these are all the use cases, and there are many, many more which we can discuss or you can answer when such kind of questions are asked. Now, there are some issues which we need to deal initially when the data is given to us. Let us say there are outliers in the data. So, any idea what are outliers?
Values beyond the specific range of the data
Right.
points.
So, as per our domain knowledge, we understand that a particular feature must have values within this range. For example, I have a sample of students on which my analytics is going on, but there is a age group in the data set which is having a value as 3, or I'll text, or 300. So that means that data is uh, some miss entry has been
Outlier.
made over there. That is an outlier. और कौन से methods हैं ये तो मैंने domain knowledge से बताया. Which are other methods of identifying outliers? कोई किसी प्लॉट से आइडेंटिफाई कर सकते हैं क्या? स्कैटर प्लॉट से आइडेंटिफाई कर सकते हैं क्या आउटलायर्स? स्कैटर प्लॉट नहीं पता. बॉक्स प्लॉट से आइडेंटिफाई कर सकते हैं क्या?
Yes, box plots.
So box plot में if there are values
Whiskers
lying
beyond
outside the
whiskers.
quartile, the 75% and the 25% quartile, then those are outliers. The second issue is with multicollinear data. Multicollinearity समझता है?
Yes.
What is that?
When
Collinearity
the
और
in
हाँ,
when
yes.
the independent variables are have the relation of linearity relation, means they are dependent on
Okay.
each other.
So, multiple independent features are related to each other, which should
Related
not
to
be
each other.
there. There should be
Yes.
a correlation between dependent and independent, not among independent. So, I'll give you an example. For us, let us say uh, we have weight, we have height, and we have BMI. So BMI is related on both weight and height. So these are redundant features, and I should not have both weight, height, and BMI. So what I'll do is, how do we resolve multicollinear data? ये तो हमने identify किया again with domain knowledge. हम मशीन लर्निंग मॉडल से कैसे आइडेंटिफाई करेंगे और फिर अगर है तो कैसे डेटा को इम्प्रूव करेंगे. So to identify multicollinearity, again we can have the heat
Ma'am,
map.
for identifying multicollinearity, we can use VIF,
Yes, we can use
variance,
VIF. कौन से
VIF,
सब्जेक्ट में पढ़ा ये चेतन?
basics of data science,
Okay,
basics of
great,
data science, machine
great.
learning and basics
Because
of data.
yeah, because this is something which I identified in my research, and that is not covered in subjects normally. So that is variance inflation factor that gives a quantification of multicollinearity. If the value is greater than 10, that means highly multicollinear data is there, and that should be removed. Otherwise, it will affect the performance. Other way of checking out is by plotting a heat map. I might get two features. Uh, which are having high correlation, three features which are having high correlations, as I give an example of weight, height, and BMI. So from there we can get multicollinearity. Then our domain knowledge will help us identify कि किस feature को हटा देना है model से for improving the performance. The third issue might be before we are trying to fit a linear regression model, might be underfitting or overfitting. Any idea about this?
I'm
Hmm.
training data and testing data. So training data is less and testing data is more. So
नहीं,
overfitting.
less और more से नहीं होता
No.
है.
Mm.
When the
It is
variance is more, then that time the model is overfitted. Means model is well perform model's performance is good in the in case of training phase, and in testing phase the model fails to perform or the
right.
performance reduces.
So that is overfitting, and the other way around is
Yeah,
underfitting. So what is underfitting?
when the bias is higher, that the underfitting takes place, the model fails in the training phase also and testing
Good. So again, underfitting and overfitting scenarios might
phase
occur.
also. There is no variation or lack of multi. What?
uh, Right, Kalyani. So again, when we are trying to fit a regression model, if ऐसा हो सकता है, our assumptions are wrong. Our data is non-linearly separable, but we are fitting a linear regression model. So our assumptions are wrong. Our our bias is wrong, and that is why the model will underfit the data. Overfitting कब होगी? जब we are trying to fit an overly complex model onto a simple data, then the model will learn that data, ratify, mug that data. But हमारा objective क्या है predictive analytics का? To be able to predict, make predictions onto unseen data. So your performance should be good on unseen data, that is the test data. So overfitting is when the model gives you good performance on training data, but the performance is weaker on test data. So there are a few examples again. For example, a person's, as I gave of multicollinearity, height and weight are multicollinear. Age and sales price of a car are multicollinear. Years of education and annual income are multicollinear. And let us say both of these are there in your data set as independent features. So these kind of data will not affect if you are trying to build a decision tree. So you can use a decision tree regressor. There is no issue because that deals one feature that deals with one feature at a time. एक particular level per एक feature, next level per next feature, and so on. But it can affect distance based algorithms. For example, k nearest neighbor. So अगर हम knn को use करने का try कर रहे हैं, then we should treat the model with multicollinearity, and then so for treating the multicollinearity, yes, Chetan, are you aware? अगर multicollinear data है, तो हम कैसे remove करेंगे multicollinearity? Because you answered very well for VIF. So PCA removes multicollinearity. That is a dimensionality reduction technique, जो कि data को दूसरे plane में ले जाएगी, and that is how the multicollinearity is reduced.
So ma'am, we should use eigenvalue and covariance.
Right, that is the
Yeah.
base of PCA.
Yeah. Okay.
So eigenvalue and eigenvectors are used, and that is how we are able to transform the xy plane into some other plane and reduce the multicollinearity. But then the data does not remain interpretable or explainable. So the cause of multicollinearity is the data might be insufficient. There might be dummy variables which I have must have created. Dummy variables कब create करते हैं?
For zeros and ones.
when we are trying to encode data from categorical to numerical, right? Or we might have included a variable that is actually a combination of two other variables. For example, पहले से height weight था, and I have also tried to create a BMI kind of independent feature. So again, that will create multicollinearity. So we can check out with a correlation if it is greater than 0.4, or we can check out with VIF if it is greater than 5. Then those features have high correlation. This is the formula for VIF. Either you can perform feature selection to reduce down the number of features, or you can perform a dimensionality reduction technique can be applied for feature engineering as PCA, principal component analysis. Or I can pick more data क्योंकि features में issue आ रहा है तो I'll increase the number of samples जो which is a tedious task, a costly task, collection of data. Or I might use a regularization technique as ridge regression. I don't know whether you are aware of that. Ridge regression क्या करता है? It penalizes higher ordered polynomials. तो it will reduce the magnitude of model coefficients जिससे कि उनका effect कम हो जाएगा onto the model. So that we'll be seeing in detail this when we move on to the last topic of this module. यहाँ तक समझा?
Yes, ma'am.
Okay.
Yes, ma'am.
So again, discussing what Kalyani answered for variance and bias. Bias error is useful to quantify how much on an average are the predicted values different from the actual values. So actually I had to get some y. I am getting y cap. The difference between the two is the error. A high bias error means we have an underperforming model which keeps on missing important trends, and this will underperform on the training data as well. While variance quantifies how are the predictions made on same observation different from each other. So while you are making predictions, while you are working on the test data, how are my result or predictions differing each other? So the y cap value, how is it differing at each run? A high variance model will overfit on your training population because it has performed well on the training data, but it will perform badly on the test data, any observation beyond training. So this is a formula that says error. Total error is bias square plus variance plus there is always an irreducible error. How much well you work on the model, that error is inherent in the data that we have collected. So these are the examples of underfitting. I have this non-linear data, but I am fitting a very simple model that is a linear regression line. So you can see that there are many errors happening in the prediction. So this is my prediction line. For this x, this should have been the value of y, but for this x, the value predicted is something like this. And similarly for all other data points. Then overfitting means I am drawing a line that is very well trying to map to my training data points. But इसने इतना अच्छे से fit किया है training data points को that if any data point lies beyond this particular fitted model, then definitely there will be a misclassification. So this is termed as overfitting. This will not perform good on test data. It will perform well on training data. And this is something lying in between. You can see that this is not as simple as a straight line, not as this complex as this high order degree polynomial. So we have tried to reduce down the degree from here to here and increase down the degree from here to here. So this is an optimal or appropriate fitting that will give you not an underfitted model or not neither an overfitted model. Now this diagram talks about the bias and variance combinations. Low bias means actual जो red circle पे हमको dot मारना था, all of the dot points are near that. That means this is a low bias model. And the predictions, which are those blue points, all are cohesive. For high bias, high variance, we see that from the center where the target was, all of the data points are away, and all of these data points are away from each other as well. That is a significance of high variance as well. यहाँ पे क्या हो रहा है? This is high bias means all of the data points are are away from the center जहाँ पर result आना था, but it has low variance means that all of the data points which are made for prediction, all of them are cohesive. So every time when you run, you get similar results, but all of these results are wrong. So this is a very bad model. Similarly, all of the data points are somewhere near to the result that is required, but every time you are getting a different value. So there is a lot of variance in the results, but the model is having low bias. During the training, it is even in the training or in the testing phase, it is not able to perform well. So this is what we want from this particular equation. As and when the model complexity increases, the error goes on reducing on the training data. But अगर टेस्ट डेटा पर एरर बढ़ रहा है, that means this is the model is having high variance and it is overfitting the data. When the model complexity is low as this linear regression line, then the model will underfit as we saw over here. It will be high bias model because we are making wrong assumptions. Data is not linearly separable, but we are assuming that data is linear regression line. Se it will be able to fit the this line as a model will be able to fit the data. So again, this will be a low error on test data, sorry, high error on test data and high error on training data, a high bias model and underfitting the data, but because it is an overly simple model. So we want something nearer to this. इसके लिए ना बाद में I don't know, it is not there in this syllabus or maybe you have must have studied in some other subject. We plot learning curves. So learning curve is a curve on the sample data. What is the performance on the training set? What is the performance on the test set? And हम वो sample size लेते हैं जहाँ पर दोनों का gap minimum है, and that we call as generalization error. कि इतना मिनिमम गैप अगर है मेरा ट्रेनिंग एंड टेस्टिंग में, देन इट इज अ गुड मॉडल. वी शुड नॉट हैव अ लार्ज गैप बिटवीन द ट्रेनिंग परफॉर्मेंस एंड द टेस्ट परफॉर्मेंस बिकॉज आर फाइनल प्रिडिक्शंस आर टू बी मेड ऑन unseen data. This is clear?
Yes, ma'am.
Okay. And then we move on to the actual topic, that is linear regression. It is a supervised machine learning algorithm for predictive modeling. So why is it supervised and not unsupervised?
When the label data is present, the supervised learning machine
Right.
learning.
It tries to find out the best linear relationship that describes the data you have. And we have a scatter plot on which all the data points are there. And we are trying to fit a line that best fits all of these data points with minimum error. It is assuming that there exists a linear relationship. That is why we are trying to fit a linear regression line. And that is why वो bias का concept आता है कि हमारे assumptions गलत हो जाते हैं. That is why we have a lot of error. So the linear relationship is assumed between a dependent variable and an independent variable. The value of the dependent variable is a continuous value, as we have discussed. The model represents a linear relationship between a dependent variable and an independent variable via sloped straight line. And this line we call as best fit line. Anyone, any idea कि best fit line क्यों बोल रहे हैं उस regression line को? सेम कॉन्सेप्ट हमारा हाइपरप्लेन में भी आता है इन एसवीएम. On the scatter plot, there could be multiple lines that can be plotted, as you can see over here. बहुत सारी lines की possibility थी. Why did I choose this line as a linear regression line?
Because it fits the most of the data points on it.
Right. And then how do we identify कि best fitting line है? By computing the error. एरर कैसे निकलेगा? इस x की वैल्यू पर ये y की वैल्यू आनी चाहिए थी, बट दिस इज अ y कैप वैल्यू, तो डिफरेंस इज कंप्यूटेड vertically parallel to the y-axis. So these points will fall a line on this regression line, and then this value will be the sum of this value will be computed. So that is how we are trying to find a best fitting line. So there are two types of linear regression. One is simple linear regression and the other is multiple linear regression. Depending on how do we decide simple or multiple? Depending on how many independent variables we have. So when a scatter plot shows a linear relationship between a explanatory variable x and a quantitative response variable y, we use least square line fitted. अब मैं स्क्वायर क्यों बोल रही हूँ? एनी आइडिया? अभी तो मैंने बोला था कि यहाँ पे एरर्स रहेंगे, इन एरर्स को ऐड कर देना है. So now why am I saying the errors have to be squared? No idea? So this is logic. If I have, let us say, equi-distributed data points, तो लाइन फिट नहीं हो रही उन डेटा पॉइंट्स को. यहाँ पर लेट अस से एक डेटा पॉइंट था, उसकी डिस्टेंस पॉजिटिव एरर आया, यहाँ पे भी एक डेटा पॉइंट था, नेगेटिव एरर आया. सिमिलरली आई हैड दिस डेटा पॉइंट, सिमिलरली आई हैव दिस डेटा पॉइंट, this and this. So likewise, if I go on adding these positive and negative errors, the total error will be 0. So that is not a best fit line. It is not fitting all the data points. That is why it is always advisable to take square of the errors. That is why this was called as least square line. अब least क्यों बोल रहे हैं? Because this error is to be minimized. We think of the square line as an estimate of a regression line for the population. तो यहाँ पर कुछ terminology आएगी as we have in the syllabus. Sample mean is represented as x bar and population mean is represented as mu. Any idea what is a sample and what is a population?
Sample is a part of the population, whole
Right.
population.
So let us say हमको एक project करना है on healthcare, let us say on heart disease. So I cannot have the data of the entire population of Mumbai. So let us say I take a region or data from a hospital in Kandivali, but then I have to test my samples on a region in Bandra. So maybe our sample size is not representative of the entire population in Bandra. There, the scenario might be different for heart disease, and here the scenario might be different. So we have to be very careful about the sample from where it is being taken and for which region you are trying to solve the problem. So we will write the regression line as these are the coefficients beta 0, beta 1. We also represent these as B0, B1. Again, that depends whether it is sample or it is population. So beta 0, beta 1 are considered for population if you're considering the entire data, and B0, B1 can be considered when you're considering the sample. So this is linear regression line जहाँ पर there is only one independent feature. If there are multiple independent features, this becomes multiple regression line. So B0 becomes the intercept and B1 becomes the slope. So simple linear regression is basically a statistical method to summarize and study the functional relationship between any two continuous variables. The regression line might be linear, might be non-linear. For example, population growth over time is not linear. The dependent variable depends only on a single independent variable in case of simple linear regression. So these are few examples of mathematical equations which are depending on a single independent variable, where y is a dependent variable and the other features which I mentioned over here become independent. We need to identify the values of beta 0 and beta 1 through the data. So Python पे जाएंगे तो there is a simple library that helps us identify these. But when we are doing numericals, you'll have to solve. You have to put in the values in an equation, and then we get the values of these coefficients. Excuse me. So these values are to be estimated from the data, where beta 0 is the intercept when the mean value is 0, and beta 1 is the slope. So these are few examples wherein our beta 1 is negative slope, beta 1 is 0 when it is parallel to x-axis, and beta 1 is greater than 0. And this intercept that is away from the origin, that becomes my beta 0 value. Either the relationship could be deterministic, as we saw this formula over here, the relationship between centigrade and Fahrenheit. This is a linear relationship. And when we plot this, you can see that because it is fitting in a mathematical model, it becomes a linear line. There can be non-linear relationships in data, which we need to depict using regression. As example given is latitude and mortality. So this is not linear something that at a particular latitude, when we go on increasing, the mortality might increase, the mortality might decrease. So again, we are trying to fit a linear regression line over here, and maybe the line has a lot of errors. Here, the errors were not found. But when you visualize a scatter plot, you can see that the relationship is linear. That is why this linear regression line was plotted with some errors. So this is a deterministic relationship and this is a stochastic relationship. There is a lot of randomness in data. So now because we are moving to mathematical equations and you'll require to solve these, I'll stop here because again, out of 5, only 2 of you have joined. I'll share this recording for others who have not joined so that they understand